Right, let's now take a close look at question 1 of the November paper 2 of the matrics of 2022. Right. Question 1 reads as follows. It says, the matric class of a certain high school had to vote for the chairperson of the RCL, Representative Council of Learners. The scatter plot below shows the IQ, intelligence quotient, of the 10 learners who received the most votes and the number of votes that they each received. Right, you can see the scatter plot. On the x-axis, we've got the IQ, and on the y-axis, we've got the number of votes that the top 10 kids received. Right. The statement proceeds and says, before the election, the popularity of each of these 10 learners was established and a popularity score out of 100 was assigned to each. The popularity score and the number of votes of the same 10 learners who received the most votes are shown in the table below. I think we can clearly see there by looking closely, the kid with a popularity score of 32 on the X column, the X row, received 9 votes, and the kid with a popularity score of 89 received 22 votes, and the kid with a popularity score of 35 received 10 votes, and so on and so on. So these are the 10 kids that we have, and we are basically looking at the popularity score of each one of them and the number of votes that each received. Okay, cool. Now, the first question is going to ask us to do a couple of very interesting things. It's saying to us in 1.1, we need to calculate the mean number of votes that these 10 learners received. So we are interested in the mean number of votes. So let's quickly go back and look what we are trying to figure out here. We want you to work out the mean. We all know that the mean is the average. So the average that we're going to calculate specifically for the votes means we need to go to the number of votes. This particular row that talks about the number of votes, and then we add all of them up and divide by how many they are. So I'm going to use y and say the mean, okay, of the y values is going to be the sum of all those y values scores divided by how many they are. It turns out that it's not complicated to add up all those things. I think you will agree with me. We're going to have 9. We're going to add 9 with 22. We're going to add 10. And then we're going to add 21. We add 11. We add 15, 20. We add 12, we add 19, we add 16. It's just the sum of all of them and divide by how many they are. I think you'll agree with me that we have 10 of those kids in total. So then I think the sum here divided by 10 will lead us to 155 divided by 10, and the final answer comes out as 15.5 votes. Right, that's the answer for the mean of the votes. Now, the second question is asking us to work out the standard deviation of the number of votes of these 10 learners. So I think if you look closely at what's going on in this question, they're now asking for the standard deviation. They're probably going to ask further questions about the standard deviation. So I'm going to go back and say something here. Because we are analyzing what we call bivariate data. Okay, this is true every time you're dealing with bivariate data, and bivariate data is basically where you are comparing two things, okay, two quantities. In this case, we're comparing popularity versus the number of votes. It helps for you to work out what I call the 7 parameters of regression. Only I call them that. I think it's 7 things that I feel like will help you to answer all of the follow-up questions that you are likely to get. So what are these 7 things that you have to worry about? You have to worry about the average of the x values, the average of the y values, the standard deviation of the x values, and then the standard deviation of the y values, okay? And then you're going to work out what the a value is, what the v value is, and what the r value is, which are those last three features are basically for regression, okay? We have to work out what all those are. They will assist us to work out the equation of least squares regression line. That will be the a and the b, and the r will help us figure out what the correlation coefficient is. It will tell us how closely related those two quantities are with each other. All right, so if you look closely at the calculator here, you'll see it will give you a lot of very interesting stuff about the data that you just fed it. For example, n tells you how many scores you've inserted, x bar is the mean of the x values, and then there's a lot of other interesting things that you might be interested in. So what you want now for our 7 parameters of regression is the x bar, that number 61.2, okay? That's the mean of the x values. Then the second number that we are interested in is the standard deviation of the axis. So do not use the one with SX. Okay, that's the standard deviation for a population. What we are interested in is the one with an apple symbol. So you scroll down, you'll see that 20.11. That's the one we're going to take for the standard deviation of the x values, right? And then quickly, that's the one we're going to take for the x values, the 20.11. And then you go do the same thing for the y values as well. If you, I think it's going to be 20.12 when you round off to 2 decimal places for the standard deviation of the x values. And then if you scroll down further, you'll see we've got the mean of the y values. We did work that out, and we got 15.5, which means we can be happy that things are going well so far. And then lastly, again, there's that SY. That's not the standard deviation we're looking for. The one we want is the one that has got an apple kind of like looking symbol. That's the sigma. It's a Greek letter, small letter S. Okay, that's the sigma symbol. It's 4.59. That will be the standard deviation of 4.59 will be the standard deviation of those values, 4.59. Okay, cool. So now let's go back and insert all that information in our calculator. Lastly, before we'll come back and then talk about the values for regression now. So quickly, what is our x bar? Our x bar is 61.2. Okay, what is our y bar? Our y bar is 15.5. What is the standard deviation of x's? It's 61.2. What is the standard deviation of the y values? We got 4.49, and then we are now interested in working out the regression parameters. Okay, quickly. So you go back to the calculator and then you ask it. Of course, you clear the screen and then you press alpha, you press 4 stats. It's option 8. In this calculator, I'm interested in regression parameters, so I'm going to press 1. I think you'll see we've got the value of A, we've got the value of B, and we've got the value of R. Your A is 1.7709. Your, okay, maybe 10 even. So I'm going to say 1.77 is my A value. 0.9 whatever the case might be, and our B value is coming out also as 0.22, so 0.2243, whatever the case might be, and R is 0.98, 37, and so on and so on. So these are the values that I'm reading from my calculator, 9836 or 37. Of course, you can change that 7709 to 7710 to round off to whatever the correct number of decimal places you might be interested in. So usually we ask you to work with 2 decimal places. So if you round off to 2, it's going to be perfectly fine. You can still be able to get the correct solutions. Okay, so what I'm looking at now are just the 7 parameters. If I now get any question, I will be able to answer it based on the information that I've collected about my data. Right, so 1.1.2 is asking us for the standard deviation of the number of votes that these 10 learners received. So we're interested in the standard deviation, okay, of the number of votes. Number of votes is y, so we're basically looking for sigma y, okay, sigma, small letter s from Greeks, that's how you write it. So the standard deviation of the y values, if you go back to it and you check closely, you'll see that it's actually 4.49. So 4.49 would be not 4.49 but 4.59. I don't know why I wrote 49. It's actually 4.49 it is. 4.59, not 49. Okay, 4.59, guys. Okay, quickly, let's confirm in our calculator because we have to make sure we've got the correct solution, because if we don't, then the answers are not going to come out correct. We're going to have a problem. So sigma value for y's, let's look at it closely. There it is there. It's going to be the one at the bottom there. It's literally 4,588, which is 4,59. Yes, 4,59 will be the correct solution. Right, so 4,59 is the answer that we are looking for. All right, cool. Now, we're going to move on to the next question. The next one is question 1.2. It says to us here, we need to determine the learners who received fewer votes than 1 standard deviation below the mean were not invited for an interview. How many learners were invited? So you look there and see that we've got this axis that talks about votes, right? We're interested in figuring out how many learners received less than 1 standard deviation of the mean. Okay, so if this is the mean, remember we're talking about y values, the votes are y's. So our mean value was 15.5, okay? So now we want to know, this is like a number line. It's increasing from left to right. So somewhere here on the left-hand side, you'll have a limit for 1 standard deviation, and somewhere on the right side, we'll have another limit of 1 standard deviation. So if I want to know how many numbers lie 1 standard deviation on the left of the mean, it's going to be the mean minus 1 standard deviation, okay? Sigma y in this case. And then on the right hand side, I'll have the mean plus, not that, but the mean of the y values. So let's go mean of the y values. Right, mean of the y values plus 1 standard deviation, quickly. plus 1 standard deviation of the y values. So this is like a fence of some sort, okay? Think about it as if it's a fencing value. And now we're interested to figure out which of these students will lie below and which ones will lie above. Because the question says, if you received fewer than 1 standard deviation below the mean, you are not invited for an interview. So who received fewer than the lower fence value? So what is the value of that lower fence value? Okay, quickly, we've got the mean as 15.5. We are taking away the standard deviation, which is 4.59. And the difference between the two comes out as 10.91. So who received any votes that are less than 10 votes? So if you received 11 votes, we will not consider you as a person receiving less. So we want somebody with 10 votes or less. Okay, so let's go and check how many of them have 10 votes or less in the table. So the first person with 10 votes or less is this one here. This person received 9 votes. And another person who received 10 votes will be this person here. They received 10 votes. And everybody else seems to have received like more than 10 votes, like 11 votes, 21 votes, and 22 votes. So it turns out that only 2 people were not invited. The question is asking you, how many people were invited? Okay, how many people were invited? Right, okay, how many learners were invited to the interview? So we can say, therefore, 8 learners were invited because 2 of them out of the 10 have votes that are less than 10.91. Okay, so 10 learners were invited. Right, now let's go to the next one quickly. This one says we need to determine the equation of the least squares regression line for the data given in the table. So that equation is the equation that takes the form y is a, okay, y hat is a plus bx. You need to know what the value of a is and what the value of b is. We've already computed this from our 7 parameters of regression. If you go back to the top where we wrote all the stuff, you'll see on the right hand side there I've got the a value 1.77 and my b value is 0.22. So I'm going to steal those and use them in my equation because they will always be the values that you work with when you're writing your equation. So my equation of least squares regression line is going to be y is equal to 1.77 plus 0.22x. It's a straight line with a gradient of 0.22. All right, now 1.4 quickly says to us here we need to predict the number of votes that a learner with a popularity score of 72 will receive. Now, we want to know if you have a popularity score of 72, how many votes are you likely to receive? Okay, that's not too much of a struggle because we already know what the equation of least squares is going to be. This equation relates votes and popularity. Okay, it relates vote and popularity. We know the equation is 1.77. Okay, plus 0.22x. Now remember, x is popularity and y is votes. Okay, so these here are votes. We are interested in figuring out how many votes you'll get because this one here is the popularity. Okay, the popularity score, which is the one that we were given here. So if you tell me that the popularity score of somebody is 72, it's like you're telling me what the value of x is. So I'm going to go 1.77. I'm adding this with 0.22, and my x value happens to be 72. Then what you do from here, you just compute the value of this in your calculator. You're going to get exactly 17. Okay, it's going to be 17.61, right? Then we have to obviously round it off. We always round up in this case because 17.61 is closer to 18 than it is to 17. So that means approximately 18 votes. Therefore, this person will get exactly 18 votes, just approximately 18 votes. That's what we're expecting this person to get. Okay, sweet. Now, the next question, which is question 1.5, says to us here, using the scatter plot and the table above, provide a reason why for 1.5.1. IQ is not a good indicator of the number of votes that a learner could receive. Why is IQ not a good indicator? Well, somebody might maybe say the fact that you're smart, okay, this does not actually guarantee us whether you'll be a good leader or not. Okay, we're not going to vote for you because you're too smart. We don't know about that. But let's quickly go and see if the table or maybe the scatter plot will tell us why IQ is not a good indicator of the number of votes that a learner could receive. So when you go back to the table and you look at the scatter plot, you'll see here we've got IQ on the x-axis, okay, that's the intelligence quotient, and then on the y-axis we've got the votes that the people have received. And I don't know about you, but if I look at this, I do not see any pattern. I don't see any pattern of some sort. Is maybe, for example, as the intelligence grows, if I saw the dots increasing like this, if the scatter plot was looking something like this, I would say there is like a very good reason why we could think that as the IQ increases, the number of votes would increase. Or maybe it could have been the other way around. Like, for example, I could have a situation where this is what I'm sitting with. I've got IQ on the x-axis and I've got the vote on the y-axis. Maybe something like this happens. I get my dots being scattered like that. Okay, that will obviously maybe suggest that as your intelligence increases, then you're getting less votes, which is something I don't know why it would happen, but I can't see any pattern here. So we can clearly see that this scatter plot does not show any pattern or any trend. There is nothing that we can conclude from this because the points are just literally everywhere. So there's a low correlation between intelligence quotient as well as the IC vote. So because of the scatter plot, we can clearly say to the examiner, well, there is no trend from what we've seen on the scatter plot. So we can't say IQ is a good indicator of the number of votes that somebody is going to get, right? So we'll say the points are all over the show. They're scattered everywhere, right? So points are all over, okay? They're all scattered everywhere. Okay, therefore there's no correlation here. There's no relationship of some sort. No or low correlation. We can't see any relationship that tells us that IQ will tell you if you'll get votes or not. Okay. Right, now the last one here says to us we need to explain why the prediction in question 1.4 is reliable. Why is the prediction in 1.4 reliable? Let's go back and talk about what we said in 1.4. In 1.4 we said that if you have a popularity score of 72, you're likely to get 18 votes. So if you have a popularity score of 72, you're likely to get 18 votes. Why is this a good prediction? Well, for the correlation coefficient to tell us whether something can be reliable or not, we have to actually go back and look at it. And if it has, remember, its scale is always between -1 and 1. And if it's 0 or it's hovering around 0, then there's low correlation or no correlation at all. If it's around 0.5, it will imply that there's a moderate correlation, okay? But for the fact that it's actually 0.98, that's actually 98% correlation. It means that the popularity score and the number of votes are very, very, very related, closely related. So we can clearly say that just because our R value is not 0.98, it's a good indication that yes, popularity does actually have a relationship with the votes. There is a strong correlation, okay? It doesn't cause it, okay? But there is a correlation there, okay? So we can say in our answer here, why is this prediction good? Well, it's because R is very, very big. It's actually not 0.98, which indicates a 98% correlation. So it's a very reliable, prediction. Reliable because of our R value. Okay, reliable because R is actually very big. So reliable prediction since our R value is close to 100%, because R is actually very strong. Since R is strong, okay, very strong correlation. Okay, shows a very strong correlation here. Very important. All right. So that is how you would actually look at this awesome question, which is based on stats.